Hello, and welcome to my talk. Today, I'll share with you how we at Elementor have created a fault-tolerant solution on top of our GenAI product that serves millions of users. It wasn't an easy ride, and today I want to share with you a lot of our journey and the lessons that we've learned. But first, I'd like to start up with a real story. So, several months ago, we've launched a new product. It's called the AI Site Planner. It's a really cool product. It helps professional web creators plan the website that they're going to build for their client. It starts with an agent that conducts a sort of AI-based interview with the web creator in order to understand the goals, the purposes, and the interesting elements of the website that's going to be implemented and developed for the client. Then it has some layer of sitemaps and wireframes to start off with a really good draft for the website. It's a very cool product and what is supposed to be launched on the 23rd of March this year. However, just 2 days before the launch, our OpenAI account, basically our main vendor that we have been building the product on top of, has locked our account and we were not able to make any calls. I bet that many of you right now think that back then, this is how we would look like, running around in hysteric mode, incident mode, war zone. But actually, that looked much more like this. Yes, it wasn't pleasant, but due to the infrastructure that we've developed, it wasn't that of a big deal. And we have easily mitigated the situation and had a successful launch. So before I dive even deeper, I have to start with an apology. I'm going to talk briefly about two companies, Microsoft and OpenAI. And in this specific talk, I won't be their fan. And if any of the listeners are from Microsoft or OpenAI, I'm sorry in advance. Hi, everyone. My name is Dennis. I lead the AI at Elementor. I've been in this industry for the last 17 years, 7 of which I've been practicing AI way before AI was cool. I live and breathe this topic. I try out the new tools, the technologies. I play around with all the. I live and breathe this topic. I have a lot of passion about it. I play with all the different tools, read the papers, and always try to find new technologies that can improve my life and the products that I'm building. So today I want how we've developed an infrastructure that's able to handle 1 million AI requests, how our solution is resilient to handle failures as severe as one of our main AI vendors locking up our account, and what are we doing in order to continuously improve? Let's start. So a few words about Elementor. Elementor is the #1 web platform for building websites in the world. Right now, there are around 19 million websites that were built by Elementor. And right now, there are almost 19. So before we dive in, a few words about Elementor. So Elementor is the #1 platform for building websites in the world. It's being used by professionals, and there are almost 19 million, even more than 19 million websites. It started off as a drag and drop tool that can help web creators easily build beautiful web pages and websites. But in the last 2.5 years, it's also started to add more and more AI tools. And I'm proud to say that Elementor is one of the pioneers of AI products for large scale applications. Because you know what BC stands for, right? Before ChatGPT, of course. So ChatGPT was launched on November 2022. And just a little bit more than 4 months, Elementor has launched our first AI product. We had several tools right on the start. We allowed our users to generate text, generate content for their websites, generate and edit images using AI, even write some sophisticated code using AI, like for animations. Even before ChatGPT and OpenAI had memory, we invented what we called the AI context, where users could upload some additional data about their site and the business and their tone and voice, and we would incorporate that in any AI requests. And lastly, we have some building tools that can predict the next layout and thus help web creators to be more efficient and more creative in their work. So since then, we have more than 2 million users experiencing AI, the Elementor AI products. We have more than 40 AI-based features, and we exchange monthly around 10 billion AI tokens. So the first topic that I want to talk to you about today is how we're handling 1 million daily AI requests. And to understand that, we need to go back to the beginning, because when we just started, like many companies, we started straight with OpenAI. But for those of you who are early adopters, might remember that ChatGPT 3.5 Turbo rate limit requests per minute was only 60. Think about this number. Back in the day, they allowed just 60 requests in 1 minute, something that is just not feasible for enterprise software. And also need to remember that 2.5 years ago, OpenAI wasn't that a big deal. So we, as a big company, we wanted to find a vendor that might be more suitable for us. This is why we moved to Microsoft Azure. But back in the day, their limits and support was much better than OpenAI. So it worked really good for almost a year until we built the Elementor Copilot. And similar to GitHub Copilot, it's able to predict the next line of code. The Elementor Copilot is able to predict the next layout. So let's say you have a title of your page or the next element. The Elementor Copilot understands that it's an About Us page and automatically suggests a full layout with text based from the AI context that is suitable for this section. And from there, the web creator can just click on the next section, the next section, and the next section, and basically build pages much faster. To support that, however, we had to, the Microsoft Azure rate limits simply were not in, because back in the day, even though the rate limits were higher than what OpenAI provided, they were not enough to support the Copilot abilities. Think about it for a second. We're taking a lot of context. We're firing events at almost every interaction the user is making, because we need to understand when exactly the user wants to create the next layout. Sometimes we're just moving the mouse around, sometimes we're editing some stuff, and sometimes we do need to create a new block. So we've been firing a lot of events. And besides the rate limits, I think, the more we adopted AI abilities, the harder it became to work with Azure. Because if for those of you who are working with Microsoft Azure, know that every time a new model is being released by OpenAI, it becomes available in Azure pretty fast. However, in Azure, there is a context of a region that does not exist in OpenAI. And it means that not every model is available in every region. And that becomes a very complicated thing for developers, because they need to remember that they have a region, and in every region, they need to create a dedicated resource where they will deploy the model. And then the quota, the rate limit, is across all those deploys within that region. And the developer needs to know against what region and what deploy they're working. But what happens when we need to add a new model that's not available in one region? We need to replicate the whole architecture from the start. And it's very tedious and time-consuming for all the teams. And in case you need to increase your rate limit, this is an actual form from the Azure portal that you need to fill in, understand what it is you're asking, what type of filter do you want, and in what region, and then submit this request and then get approval for additional requests. Shortly speaking, that's very complicated and tough. So we were looking for something much easier, both in terms of rate limits, developer experience, and we wanted to practice and check and test new models the minute they become available. So we moved back to OpenAI. That around that time, their rate limit was actually higher than Azure's. From developer perspective, there is nothing to compare. In several lines of code, you already are fully integrated with OpenAI. You don't know what regions and you don't care. And you can use any model you want, and you can just switch the model in a matter of seconds. But that still wasn't enough of a copilot. It still wasn't enough of a copilot. So we went to the most reliable source, ChatGPT, to see how can we get even higher rate limits from OpenAI. Basically, OpenAI suggests two options. The second one is to apply to a higher rate limits for basically engage with OpenAI and start an enterprise tier. But that is actually very expensive, and it requires us as a company to commit to a certain spend of money that we were not ready to commit yet. This is why we went with the first approach of having multiple API keys from multiple organizations and create some sort of a round robin around them to make sure that we basically have more available organizations and therefore more our rate limit becomes higher. So let's see how our infrastructure, the OpenAI multi-organization proxy works. We've created several organizations within OpenAI, and we've listed them along with their information inside our code base. Then we extended the OpenAI SDK so that developers will be very easy to work with this infrastructure without actually understanding or knowing or caring about what organization exactly they work with. What they're doing, they're simply instead of calling OpenAI service and straight going to check completion, they first call get SDK, which is our extension that basically pulls the next organization, and that is how we can work with multiple organizations and extend our rate limit basically indefinitely. That worked beautifully. It even helped us with our next product, the site planner. But if you remember, as I mentioned in the beginning, it starts with an agent that interviews the web creator, asks different guiding questions to understand the goal of the websites, and then it prepares a draft. Since we're working with professionals, we first want to create a sitemap, the bird's eye view of all the different pages, their content, the paragraphs, and the goal of every page and every paragraph for that website. Because we're doing some things that are professional for professionals, so we need to make sure we create a decent design. And only then we can move to the wireframe, to this first beautiful draft that will show both the web creator and the user, the client, how the website will look like. You can see that it happens really fast. And actually in parallel, there are hundreds of AI requests that happen here in order to generate all this content, because both the layout and the content and actually the whole structure is created by AI. So we had to have really high limits. So some takeaways. First, now once you start in developing your product and you get into production, you first need to understand that rate limits exist and you need to track them. You need to know your usage, because if you have a product and you start to expose it to a world and more users are using it, this is awesome. You just need to make sure that you're not getting too close to a rate limit. Otherwise, it might be very dangerous and your users may not like your service not being available. And in case you are getting closer, for whatever reason, just remember that you can easily create more organizations and use a shared pool around them. All right. The second topic would be how we're building a resilient AI solution. So we understood how could we handle the load and handle the rate limit, but rate limit and load is not only the case. And I would quote one of the best engineers, Mike Tyson, that everyone has a plan till they get punched in the mouth. So you would expect that this is how, if you're working with multiple AI or open AI organizations, this is how your usage and your performance would look like. Similar, because what's the difference between one organization and the second one and a different organization? Let's assume that all of them are under the same tier. You would assume that this is how the chart should look like. However, this is not exactly the case. If you actually track duration, error rate, any other performance metrics, it would look more of this. You would see that, yes, most of the time they have the same response, the same duration of request, the same error rate, but sometimes they diverge and one organization becomes much slower or even return failures while others don't. And if you actually look on the status pages of Anthropic, OpenAI, any other AI provider that you would like, you would see that it's not as green as you would expect. And by the way, you don't have to have major outages like the red spots. Even the yellow ones, that means that some of the functionality is not working, or some delays or some timeouts, is something that your product will suffer. You need to see how you can manage this, especially then not all organizations, usually in OpenAI, suffer in the same way during those outages. As we know, this is how it happens. Our users actually expect that our system will be 100% uptime. They don't care about OpenAI, if they don't care about outages, if they don't care about rate limit. They want the product that we're using, even the product that we've purchased, for example, to work all the time. So in this scenario where we see we have two different organizations, and one of them is diverging, becoming worse, while the green one is still operating at a sufficient level, what we would want is for our system not to use the yellow organization, but to actually use only the green one. And this is how we've added an additional layer for our multi-org solution in order to make it more resilient. So let's say we have a client request. It goes to our infra that has several organizations. And let's say that one of those organizations hit a certain threshold. For example, it hit their own rate limit, or for some reason it returns 500 error code or any other request within a certain time frame. And we see that it's not something that just happens once, it happens 3 times. So what our solution is able to do is to take this organization and remove it from the total pool of the organizations, mark it as a, let's say, sick organization, and work only with the healthy one. In this scenario, our client will never experience the failures that happen only in this organization. Because if we would keep it there, that means that out of 4 organizations, every 1 out of 4 requests will get an error, and we don't want that. We want to have as much successful requests as possible. And only after a while, we'll try to reconnect to this organization again. And in case it works fine, we can keep it and restore to normal. So this pattern is called a circuit breaker. It's not something new, which is something that actually comes from the electricity world. But basically, what we've done, we've extended the previous infrastructure solution by adding 2 additional parts. One is a Redis cache. We needed a distributed cache because, as many companies, we work in Kubernetes, we have different pods, and we don't want to we don't want to let every pod suffer from the same threshold. Because if we know that organization 2, for example, is supposed to be out, we don't want it to hit a threshold in one pod, and then the second pod, and then the third pod. We want it to hit a certain threshold and then be removed from all the pods. So the whole management of the organization cycles with actual pool is being managed inside Redis. And the circuit breaker basically is the management system that operates on top of all the organization and decides which organization should be removed from the pool of the health organizations and when it should be returned. And when it should be returned. We connected it to our Slack, so we actually can see. It's very nice because think about all those times where you had a certain resource that wasn't behaving in a good way, and the developer had to manually deploy some code, do some changes in order to remove it, and then set a reminder to the next day to bring it back. Here, everything is done automatically, and when we wake up, we just see this sort of a log in our Slack where we hit a certain threshold. The circuit breaker is open, it removes a certain organization, and after a while, it returns it. And no engineer had to do anything. It just works in a very resilient way. So let's go back to the story that I started this session. So 2 days before the global launch of the site planner, OpenAI locked our account. And it means we couldn't pay for additional tokens, for additional credits, and we didn't have enough credits. So the system could not work with OpenAI. This is how it looked like. We wanted to top up the balance, but for some reason we got this exception, this error, and obviously when we tried to contact someone from support, no one answered, and we just didn't have the time to wait for others. So we had to act. And this is why from the start, we knew that we didn't want to be in a vendor lock position. We didn't want to be in a position where in such case, if one of those AI vendors will fail, our product will not work. This is why we've started from day one also working with Claude. Now, there are some differences. So the migration from OpenAI to Claude is not as seamless as you would think, because there are some functionalities that OpenAI supports that Claude doesn't, like structured output, for example, and different schema validations. And the system prompts are not the same. You can have a prompt and then use it in OpenAI and in Claude. And using the same system prompt, you'll get different results. And by definition, it's two different models. So you had to adjust the system prompts a bit depending on the provider that you're working with. But this is, and although this sounds so complicated, this is something that is necessary, because if you're building a product for millions of users, you cannot rely on any vendor that for any reason will not be available. It might be out for whatever reason, and you just don't want to be in a position saying to your users that your product is not working because OpenAI is not working. You gotta have a fallback. In our case, we love automation, so we wanted to have a fallback in just one click. So what it means is that we adjusted our prompts, our system prompts, to the provider. We knew exactly if we're moving from OpenAI to Claude, the whole system works the same. What changes is just that instead of calling the OpenAI SDK, we are calling the fallback SDK, which in this case is Claude, and it then fetches the correct system prompts and additional instruction to make the responses be as close to OpenAI as possible. Yes, it's not ideal, but it's much better than being out totally. So right now we actually have this. So this is not something that happens automatically because it's a very rare scenario, but we do have a single key in our system that once we change it, moves the entire system to work against Claude and not against OpenAI, and then reverting it is exactly the same. And we are right now working on open sourcing this framework for everyone. So stay tuned. All right, takeaways from building and being a resilient AI solution. Everyone need to remember, and it has nothing to do with AI, that failure in software development is inevitable. It doesn't matter of if, it's a matter of when. Using a proven design partner like Circuit Breaker is a great solution for being fault tolerant. I think that, again, it really depends on the scenario. It really depends on the level of support and service which you want to provide for your clients. And the necessity, if it's a product that's working once a day, it's fine. But if you're working globally and you want to provide your user with sufficient coverage for the entire time, then I would consider adding an additional vendor and doing whatever is necessary to make sure it's easy to switch between them. It's easy to switch between OpenAI to Claude to Grok to whatever vendor you want, without adding additional code or changing stuff in the middle of the night. And another tip, it's not written here, but is to test this. It means that it's one thing to just build it and it's ready, but every now and then practice. Try to change the provider and see that everything is working, that the tests are hitting their limits, that the most important scenarios are passing, and the system is operational. Because what happens usually with fallbacks, they're being left behind, and then there's a difference between what the main provider, how the system is working with the main provider, versus the fallback that's usually not as good as the main provider. All right, the last subject that I want to talk to you about today is how AI solutions need to continuously improve. So earlier we said that this is what our users expect, with our system to be 100% up and always work. But actually, this is what they expect. They expect that not only the system is up, they expect that everything works great to what they expect of the system and how we use it. But how do we even know that we're doing a good job? How do we know that our system is doing what our users want? So I bet many of you right now are thinking about evals and evaluation in general. And you're correct. The way to understand if an AI system is working correctly is by evaluation. And when we're talking about text generations, it's pretty straightforward. For example, back in the day, we started to evaluate our different results in the text area. So when our users wanted to change their text of a button widget, for example, we suddenly saw that the AI was generating huge responses back. You can see here, it's a paragraph, right? On a button. It makes no sense that this type of text should be on a button. So once we understood that those scenarios exist, we added evaluations to ensure that texts that AI should generate for button widget, for example, would be different in length than a text for a heading and a text for a full paragraph. But for text, it's pretty straightforward. You put text in, LLM provides text out, and that's it. But how do you evaluate images? Because it's not only that the user asks for image of a dog and where you see the dog. Does the dog look okay as it has 4 legs and just one head? Is it actually walking or is it running? There are not only the functionality that is supposed to work, but also a certain amount of taste, right? Because someone might look on a picture and say it's a good picture, but someone else was envisioning something else. So it's hard to evaluate images, and it's much harder to evaluate a whole structure of a website, of a page, because a user can ask for an about me page and it will have 7 different sections, but the user might have a different idea of how this page should be structured. So how should we evaluate this type of interaction? So in order to do that, we had to move away from the traditional evaluations, and we've defined a success metric. We called it insert rate. Basically, for many of our features, the user had to enter a prompt, then see a preview of a certain result, and only if the user would use the image, we would mark that this specific interaction was successful. If, for example, we would click on generate again, or even close the page, we would know that this interaction ended with an empty result, and we would mark it as inserted false. Then we would keep all of this data in a dedicated database where we would see the user actual input, the enhanced prompt that as AI engineers, we are enhancing prompts and providing additional context, but we wanted to list everything in a very clear way. Then we had the full prompt with the system prompts and the additional, and basically everything that eventually goes to the LLM, the result that gets back, and the indication, whether it was inserted or not. All this information was stored for every interaction inside our database. On top of that, what we started with just manually going over the results. We would fetch the information of a day, of a week, of a month. We started first with just trying to understand what's wrong with the ones that were not inserted. When we asked ChatGPT for help, we would provide this information in an anonymized way into ChatGPT and ask it to see if it sees any similarities. And eventually, we developed our own clustering job. We even have an article, and right here have a QR code that I invite you to scan and read how we've developed basically offline jobs that are AI powered, that go through this data, create different clusters, and find anomalies, find those requests that have some common ground and they failed. A great example that I love to share is what we've noticed that but our AI job noticed that several image generation requests were not being inserted. And the AI actually, once analyzed that, it suggests that all of those requests that had transparent background actually got rejected. And the reason was so simple. The AI model that we were working on, the image generation, didn't support the transparent backgrounds. And therefore, all the images always returned with not transparent background, with a full background. And users didn't want that, so they rejected it. So the AI actually here, once scanning the information, clustered them correctly, understood the reason, and even suggested the reason for this failure. The solution, by the way, was very simple. No, we didn't change the image provider. We just added a hint that once we saw in the input that the user was typing something about transparent, we would also automatically hint and say, hey, we're not supporting transparent images at the moment. And that's it. We aligned expectations with the users, and they were much happier. Here you can see that basically every week we would get automatic responses in Slack that would get all those clustering informations with different suggestions and different insights of potential failure reasons. And yeah, as I mentioned, it found real issues, the transparent background that I just mentioned, the text length of the buttons that I mentioned before, even that our Japanese understanding was not as good as we thought it was. And yeah, many more examples that manually, especially for large scale application, is just not feasible. So you have to get some sort of automation on. So first, you would want to persist the data with all the details, get some sort of automation to scan this data on a repetitive basis, and use AI to get insights. Yeah, this is exactly the takeaways. Persist your data, define a success metric, measure a success metric, and then pick a way to evaluate success. Always start manually, always start simple. And only once you fine tune the metric and the data and everything works, then you can move to the more automatic stuff. And also you leverage AI for your needs. To summarize this session, first, not every system needs to be fully resilient and support huge rate limits. Identify first the need for scalability. Then design the solution. So if it's rate limit, we've talked about adding additional organizations, maybe changing to a different model and a different provider that has a larger context window or a larger rate limit, but in many cases, it will be just adding more resources and then controlling them in a healthy and a resilient layer using something like a circuit breaker to identify once a certain organization isn't good enough, move it away and work only with the good ones. And eventually establish a continuous improvement mechanism that will help your product and your AI solution be better. So I hope you enjoyed this session. It was a pleasure speaking to you today. May the AI be with you. Right here, you can scan this barcode and get the presentation for this talk, along with additional presentations that have been shared in the past with different recordings and different materials, different blog posts that I mentioned in this talk and in other talks. So it's everything in the same place, so it's easy for you to check. And also, it has my contact details there. So if you want to chat more about AI, feel free. Cheers.